Use the tests for symmetry to determine the symmetries, if any, for the relation f of x equals the opposite of x squared plus 1. To test for symmetry about the x-axis, we replace y with the opposite of y. Now remember, f of x is the equivalent of y, so we replace that with the opposite of y, and that's the opposite equal to the opposite of x squared plus 1. Multiplying both sides by -1, we have y equals x squared minus 1. And therefore, that is not equivalent to the original equation, and therefore it is not symmetric about the x-axis. For the y-axis, we replace x with the opposite of x. So that would give us y equals, we have the opposite, and then the opposite of x, quantity squared, plus 1. Now, when we square the opposite of x, we get x squared. Therefore, this is equal to, or equivalent to, y equals the opposite of x squared plus 1. That is the same as the original equation, and therefore, we know it's symmetric about the y-axis. So we'll write yes. Now, for the origin, we replace both of the variables with their opposites. So the opposite of y for y, and the opposite of x for x. Now we simplify this. The parentheses includes the negative, and it gets squared, so that becomes x squared. But we want to multiply both sides by -1, so that on this left-hand side we have y. Therefore, when we multiply through by -1, this becomes y equals x squared minus 1. That is not the equivalent of the original equation. Therefore, it is not symmetric about the origin. And so what we've determined that it is symmetric about the y-axis.